So I'm going to go ahead and start recording now, but we'll wait just a second for last few people to kind of trickle in before we really get started. But in the meantime, I thought I'd introduce myself. My name is Brooke Versaw. I am a third-year graduate student at Caltech in the Division of Chemistry and Chemical Engineering. So I'm working on my PhD in chemistry, which means I've been in school for a really long time. And while I took a lot of classes like the ones that you've taken now, most of my time is spent in a lab doing research, which is pretty fun. And so what we're going to be doing today is a fun demo called Pepper Skaters. And we're going to be looking at a phenomenon called surface tension. So I hope you guys are either in your kitchen or your living room and have a surface ready to do some science. I'm getting a few more people hopping on now. If you have questions for me, please feel free to drop them in the chat and I'll get to them as quickly as I can. There will be a dedicated time for questions as well when we get towards the end of the experiment, if you have any additional questions that come up.
And Brooke, just one more thing. I'm Kitty Cahalan. I'm Caltech CTLO, Center for Teaching, Learning, and Outreach. And we're excited we have Brooke here and we have Arian is the next one. And I'm going to be hopping off to help Arian set up. But Mitch Aiken is also here. He's our Associate Director of Outreach at Caltech. And if you make him a co-host, he could also help if there's any issues with that.
Yes.
But people are set, they can unmute themselves if they want to ask questions, but you can keep it muted just to keep the background noise to a minimum.
Yeah, I think I'll keep it muted all the way until the question session at the end, but if questions pop up in the meantime, absolutely ask them. Just please use the chat function to do that. Let's see. My cursor's flown off the window. Okay, Mitch, you should be a co-host now in case you need those privileges. All right, so I think we should probably go ahead and get started so we have plenty of time for science. So without further ado, let's get started. So the first thing I'd like to do is explain a little bit how surface tension functions. So we know that water is a part of our bodies, it's a part of our daily lives. We drink it, we see it in the ocean out here and in lakes. But what I do as a chemist is think a lot about water on a molecular level. And so some of you may know that water molecules are 2 parts hydrogen and 1 part oxygen. So if you can see my cursor, the structure on the left is 1 molecule of water. But when you think about a solution of water, so like the liquid you pour into a glass, you have many molecules of water, like the structure I've shown here on the right. And those kind of cling to each other through the hydrogen atoms, as I've shown here. And this is a sort of cohesive force that generates something that we call surface tension. And what that is really just a property of a liquid that allows it to resist an external force. And that's it's a function of cohesion within the liquid. So the water likes itself, but it's also modulated by interactions with the outside environment. And in terms of water, we usually describe that as either hydrophilicity, so a substance that likes water, or hydrophobicity, something that dislikes water. You can think of that as fear. A phobia is a fear. And so things that don't mix well with water are called hydrophobic. And 2 examples of surface tension that I've shown here are things like water beating up on the surface of leaves. The surface is hydrophobic, and so it repels the water. And it's surface tension allowing the water to roll up on itself and make the droplets. And another example is bugs that kind of skate across the surface of water. You might expect that water would, or that bug would be too heavy and would just sink to the bottom, but it doesn't. It actually stays on the surface and can kind of move around. And that's as a result of the surface tension on the water relative to the bug's feet. So now that we've got a little bit of an idea of how surface tension works, I thought that we could try it out ourselves. So it's science time. So these are the materials that we're going to be using. I'm not sure if you had access to these already, but if you don't, I'll give you 2 minutes to run and grab them. You're going to need a shallow bowl or a plate, preferably something light colored so it's easy to see what's going on. A handful of toothpicks, or as I mentioned, if you don't happen to have those around, you can use like bamboo barbecue skewers. You could potentially even use a pencil, although you'll want to wipe it off between uses. You'll need water, so a sink, a water bottle, something at close hand, ground black pepper, some kind of cooking oil, any sort will do, whatever you have. Canola is what I'm shown here, but olive, avocado, whatever. Some kind of dish soap or detergent, milk, any kind will do, and toothpaste. So you've got 2 minutes to gather your experimental setup, and we'll start then. In the meantime, does anyone have any questions so far? If you do, feel free to drop them in the chat and I'll get to them.
Excuse me, is this as a shallow bowl?
That's perfect. Yeah, that works great. A Tupperware is perfect too.
How water made?
Try again.
How water made?
All right, do we have our materials? Are we ready to start? Okay, let's get started. So the first thing I'd like you to do is pour some water into your dish. It doesn't have to be very much, especially if you're using something like a plate, but you want enough that you have like a standing layer. And when you've done that, go ahead and sprinkle a couple teaspoons of pepper over the top. It might be a little bit less than that depending on the size of your container. I have a pretty small dish here. You just kind of want a little layer on the top, like what I've shown here. And what I'd like you to think about right now is what you see. A lot of science is observations. So right now, we're going to think about what we see. Is the pepper floating or is it sinking?
It's floating.
Exactly. Why might it be floating on the top of the water?
Pepper's light.
It is very light, that's true. But could it also be that it's a little bit like the bug that could sit on the top of the water?
Some of it is sinking and some of it is floating. Why is the pepper spraying?
That's actually related to what we're about to talk about.
Like it thinking.
It's not.
Yes, something is.
So the pepper is going to be floating on the surface, and some of you may have observed that it's spreading out over the surface too. And that's because pepper is hydrophobic. If you remember that word hydrophobic, it doesn't mix well with water. And so the water is going to essentially repel the pepper, and so it's just going to kind of stay put on top, just like the bug that we saw, or just like the water curling up on the leaf. So next, we're going to try and make the pepper skate around. So what I'd like for you to do next is to take one of your toothpicks or pencils or whatever you've got and coat it with a little bit of oil and then touch it to the surface of the water. And then what you should see is something like this, right? Did you see anything happen? Did it move around? Did it kind of stick? I see a hand up.
I noticed on mine that it just like there was like a little underwater bubble that won't pop. It just it gets smaller and then gets bigger anytime you try popping it.
Yeah, that's probably a function of surface tension too, especially if some of the pepper got pushed down a little bit.
It skates around.
Just a little bit though, right? It kind of stops moving when you stop moving. So what we're gonna do next is try adding dish soap. So take a new toothpick and coat it in just a little bit of dish soap and then touch it to the surface of the water and think about what you see. I'll give you a second to do that and then I'll show you on my screen what I saw.
It repels.
Yeah, did you see something like this where it moves away really fast?
I agree. It repels a lot. As soon as I put it in.
So we're gonna think about why that is, and I'll come around and we're gonna explain it in just a minute. But in the meantime, go ahead and rinse out your dish and then refill it with water and sprinkle some pepper over the top.
Once I put my toothpick into the pepper, it spread it out like there was like germs.
It sure did.
Picture I got.
Does everyone have their new dish of water and pepper?
Because the pepper, it like doesn't like the germs and it like runs away from it.
That's a great observation. Doing great. All right. I think as you finish up getting your kind of reset of your setup, I'm going to explain what you're going to do next. Oops. So the next thing we're going to try is milk. So coat a toothpick with just a little bit of milk and then touch that to the surface. And this time I'm going to challenge you to try thinking about what you think it's going to do before you touch it and just kind of hold on to that thought and then see if it matches when you touch it to the surface. Do you see that it didn't move? You'll see I refilled my dish here, so there's a lot more pepper on the surface. That's unrelated.
Nothing happens when you put the milk on the toothpick.
That's a great observation.
It doesn't move at all.
Yeah.
On my
question?
when I do it, it just picks it. The toothpick just picks it up like this. It just if it goes near it, it just picks it up.
Exactly. I saw that too.
When you put them in the pepper, it sticks to the milk. Maybe the pepper didn't. For me. Maybe the pepper didn't spread milk.
All right, you guys, we're going to try one last thing. So this time we're going to try adding toothpaste. So go ahead and coat a toothpick with a little bit of toothpaste, just a little bit. I know it's sticky, and then touch it to the water. And again, think about what you're going to see before you do it and see if it matches up. I will warn you that this particular test is a little bit trickier. I tried this with a couple of different brands of toothpaste and actually got different results depending.
For my toothpaste, it makes it repel. It makes it
smell only a little bit.
Mine just were like a mile away.
Some water.
Yeah, so this is what happened when I tried it. It repelled it, but just a little bitty bit.
Oh, ours was much.
I did it. It just
Yeah.
repelled a lot.
Some people's might repel a lot, some
But
people's
for me,
just a little bit.
it repelled like a lot.
So now let's kind of talk about what we saw and why it happened. So we talked about why the pepper floated on the surface of the water, right? That the pepper is hydrophobic, it fears water, and so it stays on the surface instead of sinking. But now let's think about what we saw with our toothpick tests. So which of the substances that we tested made the pepper skate? It was the dish soap and the toothpaste, right?
Maybe the toothpaste, maybe.
So let's think about what those have in common. So what did dish soap and toothpaste have in common? Does anyone have any suggestions, any ideas?
They have chemicals in both of them.
They do, they absolutely do, but so does milk and so does oil. Everything is a chemical.
It's an acid and they clean.
I'm seeing a comment that they're both bases. That is, it's not quite true. Killing bacteria. Some soaps are antibacterial, but they're not all antibacterial. Toothpaste in particular isn't. Many soaps are bases. That is correct. I'm actually looking for something that's a little bit more commonplace. They both clean things. Dish soap cleans your dishes. Toothpaste cleans your teeth. And one property in particular that both of these have that you may not have learned yet is that they're both called surfactants, which means that they break down surface tension. So what you're seeing when you drop a toothpick with some soap on it or some toothpaste on it into the solution is that the surface tension around the toothpick was broken and then the water moved away because the water is still coheres to itself, but it takes the pepper with it. And that's actually what happens when you have, something stuck to a pan and you use dish soap to try and clean it off. That's exactly the same kind of phenomenon that you're looking at here. I'm seeing a question about how soap cleans your hands if it's not antibacterial, and this is actually how that works. A little bit. So some surfactants can also help open up membranes in bacteria, and so they can be antibacterial by means that dedicated antibacterial agents are not. I understand that's a particularly relevant question right now, so I wanted to go ahead and address that one. And with that brings us to the end of our demo. So thank you so much for joining me tonight. Please don't forget to be a responsible lab citizen and rinse out your dish, throw away any used toothpicks, clean up any spills. And at this time, I'd also be happy to take any questions about surface tension, about this experiment. If you can drop them for me in the chat, that'll help me answer more of them and make sure that everyone gets their questions answered.
Thank you. Thank you.
You're welcome.
Thank you.
You're welcome.
Thank you. This thing was so good. Thank you. I want one.
So glad you enjoyed it.
Thank you. Bye. Thank you. Bye.
Thanks for joining.
Thank you.
Thank you.
No. Okay, let's go to the next one.
Thank you. Thank you.
Leave.
Thank you.
You're so welcome.
That was great. Thank you.
So welcome.
They loved it.
I hope so. I think it's a fun check.
Yeah.
And something you see so often in kind of our daily lives, and we don't think about that much, but
yeah, terrific. Yeah. We're gonna go check out Arian's. So take care. Bye.
Awesome. Take care. If there's no further questions, I'll go ahead and end the meeting. Thanks so much for joining, y'all.